Welcome again to Kitchen Chemistry with Mr. Gridley. We are discussing acids and bases today. Today we have with us an indicator, a special indicator. Our indicator today is Congo red solution. So here is our Congo red solution. And I took some Congo red and we went ahead and put it into, and we dissolved it into water. So a little bit of Congo red and a lot of water. So here is our container filled up with Congo red and water. Each one of these has been filled up with the same Congo red and water. And we're going to go ahead and see if there's a change in color when we have acids and if we have bases. So Congo red is one of many indicators. Phenolphthalein is a common indicator that's used. Red cabbage juice is actually one of my favorite ones. We didn't have cabbage juice today. We also have another indicator, methyl orange. That's another one as well. There's probably 20 or 30 different indicators that will change color, not necessarily right at a pH of 7, but sometimes a little bit on the acidic end or a little more on the basic end. But these are sort of a good way of indicating, hey, something is a little bit more basic or a little more acidic. And so let's go try. Let's go ahead and start on the end with Congo red and a cleaning agent, okay? Pine Glow. I happen to pick up Pine Glow at an estate sale, and we're gonna add a little bit of Pine Glow to here and see if we get a little bit of a color change. So our first one was Pine Glow. We'll put that there and we'll try to compare it to the other ones. Did we get a little bit of a color change? Maybe a little bit, sort of a lighter yellowish, okay? A little lighter yellowish substance, okay? For our Pine Glow, that's our first one. A little lighter in color. Our next one is Mold and Mildew, bleach-free, okay? CLR, Mold and Mildew. Again, these are household items. We're pretty safe. And we'll spray a couple sprays in here. There we go. Ooh, it's nice and foamy. Isn't that nice? So CLR is our next one. And we'll go ahead and mix that one up a little bit. And we can see our first one. And again, it's similar in color. We'll get another cleaning supply. Notice, okay, many of the cleaning supplies will all have the same kinds of properties. This one is Sparkle Glass Cleaner. Again, I think I purchased this one at the same estate sale. And once again, we're seeing this same color. There apparently doesn't seem to be any color change during the time period in which we're adding cleaning agents. So all three of these cleaning agents really have not changed the color per se. Let's go add a fourth one. Let's go add some baking soda. Baking soda is also another cleaning agent. So here's some baking soda. We'll get a scoop full of baking soda and add it to our last small container. And here's a small scoop of baking soda. Here it is, the baking soda. And we can add one scoop. Notice we're very qualitative in our assessments. We add 1 or 2 scoops and we stir it up and we look for color changes. Now all of these ingredients are all bases. Cleaning agents by and large are almost exclusively bases. There's a little bit more than 7 on the pH scale. So we're going to move some of these cleaning agents off to the side. And the color did not significantly change. This one might have had a little more of a color change to it. It might be because this is actually yellow in color, all right? But we don't get so much of a color change. So when this indicator, Congo red, is in the presence of a base, it's going to be this sort of reddish color. We can see it there. Great. Let's now try some acids. So what are some acids? Acids are pHs below 7, and one of the most common ones we're thinking about is a lemon. Lemon, lime are all citrus fruits. These are going to be more on our acid scale. So we're going to try our last one here. Here's our Michigan ROTC cup. Our oldest son is a graduate of Michigan. He went through the ROTC unit there. And let's go ahead and squeeze some nice lemon juice in here. There we go. Aha. Aha, we are getting a color change. Notice the lemon is yellow, so there is no reason for this to go ahead and turn to a bluish color. So in the presence of an acid, this Congo red turns more of a bluish color. We'll take our lemon out. We'll fish our lemon out. There it is. Turns more of a bluish color in the presence of an acid. What else is an acid? Vinegar. I've got our Costco size container of vinegar. We'll try this one over a little bit here. Here's a nice clear cup we were able to find. We'll add some vinegar. And ooh, look at that. That was a great color change, wasn't it? So in this case, vinegar is a great example of an acid. So there's different kinds of vinegar. You can buy fancy kinds of vinegar. You can buy the cheap vinegar. You can buy the balsamic vinegar, your oil and vinegar salad dressing. The vinegar portion of it is going to be an acid. I know some people will actually go ahead and just eat a lemon, all right? That's very, very acidic. Now, if you eat a lemon, are you going to become acidic? Is your body going to become acidic? No. Your body naturally produces bases to counteract the effect of acids you eat. So please don't worry if you're eating vinegar on thinking that your body's going to turn into an acid as a result of that. Your body has special buffer systems in place so that does not happen. Our last one we have is salicylic acid. Now here's some salicylic acid. Salicylic acid is found in a number of areas. You can find salicylic acid in wart remover at high concentrations. You can also find it in your face cream. So many face creams when you're 15, 16 years old, you're breaking out, that's natural, you just have those days. And many of your face creams have maybe 1 or 2% salicylic acid, okay? Wart removers might be about 5 or 10, maybe even 15% salicylic acid. So here's some pure salicylic acid. And we're going to put this into our Oberweis 5K run. Yes, I did a 5K run, and I think they gave us a chocolate milk afterwards. So let's see what happens with salicylic acid. We know it's an acid, and we add it to there, and yet it looks like it's staying the same color as all of our bases. So that's a little bit troubling, and we were to say, well, that doesn't make sense at all. It's an acid. Now, it might not be acidic enough to turn these a different color, but the one thing we haven't done is we haven't taken the acid and tried to dissolve it in the water. If I look at it, it looks like the acid's just sitting on top of the water. It's not really mixed in. So let's try mixing it in and see if that makes a difference. So we go ahead and start mixing some in, and maybe we start to add a little bit more. Oh, there we go. Aha. Okay. Notice, acids are acids when they get dissolved in water. So there are things that are solid acids like salicylic acid, citric acid, but they're acidic once they actually dissolve in the water, once they become an aqueous solution. So that acid sitting on the top did not change in color because it really was not interacting with the water. Salicylic acid is only slightly soluble in water, so we can see there's still some chunks that haven't quite dissolved. That's why it's a little bit tricky to get it to mix in. So we're seeing acids and bases in the presence of Congo red, our indicator for today. We could have also used some pH paper as well. We might as well try that. We have a few more minutes. So we have pH paper, and we can line up our pH paper. Our pH paper goes from 7 to 13, and this is a different indicator. And on the acid side, down to red. So it's a different color indicator. So here they come. They come in strips this big. You can go ahead and cut them in half and use only half the size of it. Reduce, reuse, recycle, okay? So all we have to do is dip it in here and take a look and see what we're getting. This one is pretty close to our neutral. So here we are sort of somewhere in our neutral range. So that was one of our cleaning agents. We'll try our CLR, our chlorine-free bleach CLR. And that's getting us a little bit of blue, a little hint of blue, which would be more on the basic scale. So we're getting maybe up here in the green and maybe a hint of blue more on the basic scale. We'll try 2 more. We'll try our baking soda. Our baking soda was here. And for sure we're getting something upper in the green. So here's maybe an 8 or a 9, maybe closer to a 9 on our baking soda. And then our glass cleaner, our sparkle glass cleaner, again, not too acidic nor basic, so somewhere close to our 6 or 7 range. We tried the same thing again with our acids. So our first one we added was our lemon juice, and we'll dip it in. And we can see with our pH paper, we are pretty darn close to 2s and 3s on our pH paper here. Our next one was vinegar. Again, this is going to change it to sort of a reddish color, so we're matching up maybe about a 3 or a 4. And our last one we're going to add is the salicylic acid, a white powder. And we'll cut them in half because we really don't need the whole thing. So our salicylic acid, a little bit of it dissolved in water, and we can see that on our scale, once again, we're probably close to maybe a 3 or a 4. So we do have some indicators. There are different indicators. Our pH paper is a different indicator than Congo Red, but I wanted you to get some experience seeing acids and bases change color with special indicators.